Hello, and in this video we're going to look at whether every function has an inverse function. So we're looking at the existence of an inverse function. We're going to take a look at a simple function, y, or f of x equals x squared as our beginning example. We're going to type that into our Desmos function here. Y equals x squared, and this is our function, y equals x squared. We're going to take a look at this in terms of whether it has an inverse function. Now remember on the previous example, to find the inverse function, what we do, an inverse function, for inverse function, the main algebraic thing is we switch x and y values. Okay, so if we had this as our function, then our inverse function, would be, instead of y equals x squared, it would be x equals y squared. So let's take a look at that graph. What does that graph look like? And see if it is a function. So we can type that into Desmos as well. So we're switching the variables, x equals y squared. And if we take a look at this, we switch the x and y values. You can see 1, 1 is still at 1, 1. But if we went over to 2 and 4 up here on this graph, 2, 4 is now 4, 2. And negative 2, 4 is going to be 4, negative 2. We can take a look at this green graph. This green graph is not a function because it doesn't pass the vertical line test. The vertical line test has to cross once, and we don't have that here. The original function, the original graph is a function, but this is not a function. So by switching the x and y's, we do not have a function on this, just our general basic parabola. So we start with a function that looks like this, and we get an opposite one that looks like this. Okay, and that is not a function. So it doesn't pass the vertical line test. We draw a vertical line here, and it's not crossing once. Therefore, this is not a function. So what we're saying here is not every function has an inverse, not a function. Now we can make it a function by restricting some of the domains of the original function. We can always make it a function by restricting it. Now what we have to know to make sure that an inverse happens is the function has to be one-to-one, what we call one-to-one function. So we're looking for a one-to-one function. A one-to-one function always has an inverse. A one-to-one function is where we have one element in the range for every exactly one element in the domain. So this one didn't work out because our range value of 4 here, okay, on this graph, the range value of 4 had two domain numbers. It had a 2 and it had a negative 2 as its answer for 4. So there were not exactly one domain value that gives you 4. And that's why doesn't have an inverse function. Okay, but if it's one-to-one, then it has exactly that. Now we test one-to-one functions with what we call the horizontal line test. So it's just like the vertical line test, but if it passes the horizontal line test, crosses once, then it is one-to-one, one-to-one, and has an inverse. So any kind of graph that we graph, let's say we did this, if we turn it all like this graph, if we had this graph like here, this would not be one-to-one, because if we tried to draw a horizontal line, it would cross 3 times here. 1, 2, 3. It's not one-to-one. Okay, so this is not one-to-one. We'll abbreviate here. Not one-to-one. Okay, but if you have a graph that looks like this, same type of graph, but it just goes this way, then we can draw a horizontal line anywhere, like here or here or here, and it would only cross once. So this is one-to-one, is 1, 2, 1, and has an inverse. That's a function. This one has an inverse, but it's not a function. So we can make an inverse relationship out of this graph, but it's not going to be an inverse function. So in order for a function to have an inverse that's a function, it must pass both the vertical line test and the horizontal line test. So for a function to have inverse that is a function, graph must pass both vertical and horizontal line test. And horizontal line test. So the vertical line test is for the original one to be a function, and the horizontal line test is for the inverse to be a function. So both of those tests have to pass in order for it to have existing that it is a function. We can always draw an inverse. We can always draw an inverse, but we're specifically looking for an inverse function here. So we can make an inverse from any graph. All we have to do is switch the x and y. So the inverse automatically happens when we do this. All right, when we switch x and y, we get an inverse. But in order for the inverse to be a function, it has to be one-to-one and pass horizontal line test for the graph. And that's how we would make sure we have an existence of an inverse function.